let's use an example to try to make sense of all this. Okay, so here's our research question. It's actually from a former grad student. Will there be a significant relationship between learning a motor skill with a dominant hand and transferring the skill to learn the same motor skill with a non-dominant hand? So let's identify the variables. X is learning a motor skill, and Y is transferring that motor skill to the non-dominant hand. So that was his research question. Now we want the null hypothesis, because that's what we're going to test. There will be no significant relationship between learning a motor skill with a dominant hand and transferring the skill to learn the same motor skill with a non-dominant hand. Okay, so he set up a test, a research study to test this null hypothesis. Now, let's talk about his methods. What did he actually do? He actually used a high school class. He had 3 different classes. He had he used 2 different classes, but 2 classes did the same thing, and 1 class was the control group. Now, a control group is a group that doesn't do anything. They do the test and pre-test, post-test, and that's about all they do. So he got Fresno Pacific University IRB approval, got approved by the principal to do the study. He had the parents sign the informed consent. He taught the students how to collect the data. He taught the students how to juggle. He gave them a demonstration of the task of juggling 2 tennis balls with a dominant and a non-dominant hand. He asked any questions that the students may have had about actually doing juggling and how to actually collect the data and proper scoring techniques. Previous knowledge of juggling was not really significant to this study. It was just the whole purpose of the study was transferring motor skill. And so they had the subjects had 5 minutes to do this skill. The participants attempted to juggle 2 tennis balls with their dominant hand for 5 minutes. The trial started when the participants threw the first tennis ball in the air and ended when the participant failed to keep the tennis ball moving in continuous motion. I think most of you have done this in Dr. Snyder's class, in the program design class. It's basically what this researcher did. The participants earned a point for each catch. A catch was when one tennis ball was caught and the other tennis ball was in air in continuous motion. The subjects were partnered up, and the participant who was not juggling recorded the scores on their partner's data sheet. Each trial had a score even if it was 0. When the 5 minutes was over, the participants recorded data for their partner for their 5 minutes. Then they switched. The person who was keeping score now juggle for 5 minutes. This process continued for 10 days, and when the 10 days were over, they started part 2. In part 2 of the study, the participants performed the exact same test as part 1, except the participants used their non-dominant hand. After 20 days, all students or subjects calculated their mean scores, their final mean scores for the 10 days for their dominant and their non-dominant hands. The control group in this study, what they do is they perform on the first day, they did a pre-test with their dominant hand, and after the 20th day, they did a post-test with their non-dominant hand. Okay, so that was the study. Let's look and see what was found. Okay, so we have here's the group mean values for the experimental and the control groups. So let's look at this chart so we can decipher what all this means. So the group, we had 122 subjects in the experimental group, and we had 63 subjects in the control group. It would have been better if we would have had equal numbers, but we had no control over that. Now, the M is mean. So the dominant experimental group had a mean of 7.26 catches in the 5 minutes with a standard deviation of a 16.01. Pretty big spread. The non-dominant experimental group had a mean of about 5, so 1 per minute, and the standard deviation is around 5, so closer. We're going a little bit slower because it was probably a little bit harder with the non-dominant hand. Our control group, both the dominant and non-dominant hands were around 2, really much lower, and the standard deviation is around the same. So you know that we actually did run a t-test on these, and we did find, in t-test you'll learn what is in the next podcast, we did find a difference between the groups, but we'll explain that later. So after we ran the descriptive statistics, we ran the Pearson's correlation comparisons, and the key things I want to focus on here is the R and the R squared. You'll see in the dom and non-dominant experimental groups they had a R level of a 0.78 with a p-value of greater than 0.05. That means there was significance there, and that means that those two variables were related. You also notice that the control group had a greater level of relationship, but even those numbers are a little iffy, because if you look back at the control numbers, they're very close anyways. It doesn't really mean there was much of a relationship there. Just so you know what R squared is, you can see that on the chart here, R squared. R squared is called a coefficient of determination. This tells us how much the variable x actually has an influence on the other variable y. What we do is we square R. So we take, and for our example, we squared 0.78 times 0.78, which equals a 0.61 rounded up. What this means is that approximately 61%, we take 0.61 times it by 100, and gives us 61%. Approximately 61% of the relationship between learning a motor skill with the dominant hand and transferring that skill to the non-dominant hand could be explained. How it can be explained is by practicing a motor skill, that the skill was actually transferred by practice. That's what it means by being explained. That relationship between the dominant and non-dominant hand learning that skill can be explained by the practice that the person did. So what? So we did this study, we ran all these numbers. So what? We got to answer the research question. Do we reject or do we fail to reject the null hypothesis? Just so you know, we calculated a t-test. We found significant differences between the experimental and control group scores. And what's going to come next is actually from the research project. Okay, so this is the so what. Tables 3 and 4 reveals that there was a significant difference. Now let me talk about the term significant differences. Statistically speaking, significant differences mean that one group, the experimental group, the dominant hand, non-dominant hands for the group, those are two groups. They were different from one another. And statistically speaking, they were significantly different from one another. Even though the numbers may not seem like it, they were different from each other. Okay, so tables 3 and 4, which are the descriptive statistics, reveal that there was a significant differences between the dominant and the non-dominant hand for the experimental group, and the T is a statistical test. Tables 3 and 4 reveal that there was a significant difference between the dominant and the non-dominant and control group. So the experimental group and the control group numbers were significantly different from one another. It was found that the group mean for the experimental group was higher than for the control groups. This means that a higher level of acquisition occurred because the experimental group practiced their motor skill each day of the study, while the control group only performed a pre and post test for the acquisition. Now this is kind of critical. I want you to answer the research question, which is the very first part of this, then explain why there was a difference. This is answering the research question. We rejected the null hypothesis because there was a difference between the two groups. So we rejected the null hypothesis. We went back to the mean average, the descriptive statistics, to determine why there was a difference between those groups. Okay, that was the groups are different. Now what about the correlation? Because that's really what the researcher wanted to know about, was there a relationship between them. Tables 3 and 5 indicate that there was a transfer of motor skills. Hey, there's the key, ding, ding, ding. There was a transfer of motor skills between the dominant and the non-dominant experimental group. R is the statistic, 0.78 with a p-value of 0.01. With approximately 61% of the variance explained, and there's the R2. Tables 3 and 5 indicate that there was a transfer of motor skill between the dominant and the non-dominant control group. R equal to 0.81 with a p-value of equal to 0.01, with approximately 66% of the variance explained. The relationship in the control group could be explained by the similar mean scores from the lack of practice. They really didn't change. That's why the R scores were so close. So in the long run, yes, these groups of physical education students were able to transfer the motor skill between a dominant and a non-dominant hand. And practice did make a difference on this. This is chapter 4. Chapter 5 is after this is where you write what this means. And that's a whole nother series of lectures. So that is your basic correlational research in a nutshell. There's another type of correlational research that's called multiple regression, also known as regression analysis. I'm not going to spend too much time on this. It gets kind of confusing. Again, we're looking at a relationship between one particular dependent variable, which is again called a criterion variable, and two or more predictor or variables are independent variables. We want to predict something, and the best example I can give for this is when we do percent body fats. When we use the skinfold calipers, we measure various skinfold. Let's say we do the tricep, abdomen, the stomach. I can't say the word now. The stomach and the thigh. We do those 3 times. We come up with numbers. We get an average, and we're going to plug that into an equation. We use that number to calculate body density. That's a prediction equation. Actually it's a multiple regression equation that allows us to predict if you have these measures, this is basically what your percent body fat will be. There's all sorts of different types of equations like this that allow us to predict how somebody's going to act in the future, or based on these skinfold measures, what is our percent body fat. So again, they're predictions. They're pretty involved. They're doable. We can do something like that here in our graduate program. Actually, we have a student that is working on one from last year's cohort, soon to be finished. So that's a multiple regression. So if you see that in any of your research, you kind of understand what they're doing is they're trying to predict future outcomes on something. So let's review what we've talked about. Correlations are used to determine a relationship between two variables. Again, a relationship is not cause and effect. There's some kind of interaction between X and Y, and then X has some kind of influence on what Y does. So For example, we talked about transferring of motor skills. Practicing or learning a motor skill on your dominant hand has a relationship with learning that same motor skill with the non-dominant hand. There's a relationship between there. It's a pretty strong relationship between that. Then another thing we can do is we can look at multiple variables in regression and allow us to predict future outcomes or future results based on a regression equation or multiple regressions. You have one dependent variable and two or more independent variables. I hope that this has made correlational research statistics a little bit more understandable. We'll talk about this when we get into experimental design in a couple weeks. Please read the chapter. This will help this is kind of like the bones the chapter will give you to meat to have a further understanding of this material. Now you should now listen to the next podcast for chapter 9. Again, print out the PowerPoints before you open up that podcast.